Phases of the moon. In this video, scientists will be able to comprehend why the moon has phases. To start, let's discuss the motions of the moon as it goes through space. The first is that the moon rotates once every 27.3 days around its axis. So it takes the moon roughly 27 days to spin one time. The moon also revolves once every 27.3 days. So it takes the moon 27.3 days to go around Earth one time. You'll notice that the rotation and the revolution are the same. What this means is that the same side of the moon always faces Earth. You've never seen the back of the moon. Next, it's important to talk about how we can see the moon. We can see the moon because sunlight reflects off of it. Because the moon is in space, and one side is facing the sun, half of the moon is always lit up. It's also important to remember that the moon does not create light. It reflects sunlight. Now, a natural question is, if half of the moon is always lit up, what creates the phases? Why doesn't the moon always just look half lit up? So to go back to phases, we call the different shapes of the moon that we see on Earth phases. Again, it's the name we give to the shapes that we can see on the moon. And the phase of the moon, so what we can see on Earth, depends on how much of the sunlit side of the moon is facing Earth. Again, half of the moon is always lit up. The phase depends on how much of that lit up side we can see. And this really depends on the position of the sun, the Earth, and the moon. On the left, you can see the moon going through the phases. You'll notice that the lit up side appears to get brighter, and then the shadow side appears to get bigger as well. This pattern repeats itself every 27.3 days, where the lit side appears to get bigger, and then the shadow side appears to get bigger. It's important to note that the light side and the dark side on the moon grow from the right towards the left. The best way I remember is to think about flipping the pages of a book. Imagine you're flipping the pages and the light side is getting bigger, and then you flip the pages so that the dark side gets bigger. So, why does this happen? In this diagram, we're looking down on Earth, and you can see the moon revolving around the Earth. The moon is going around the Earth. Remember that it takes 27 days for this to happen. And notice that half of the moon is always lit up. Regardless of where the moon is, half of it is always lit up. What's important is what we can see from Earth. In this example, the dotted lines from the Earth to the moon represents what we could see. So let's start with the moon positioned all the way to the right. If you were standing on the surface of Earth, looking up at the moon, you would only be able to see the dark half of the moon. The entire moon would appear to be in shadow. We call that phase the new moon. A few days later, if you were looking up at the moon, you would notice that most of the left side of the moon is still in shadow, but you could begin to see on the right side a bit of the lit up side of the moon. Again, half of the moon is always lit up. But where you're standing on Earth, relative to where the moon is in space, you would see a small section of the moon lit up. That next phase is called a waxing crescent. As the moon is a quarter way around the Earth, now you would see exactly half the moon lit up. That phase is called the first quarter. After that, the lit up side would continue to look larger. This next phase is called a waxing gibbous. Notice how from new moon towards waxing gibbous, the lit up side appears to be getting larger. Keep in mind, half of the moon is always lit up, but we are starting to see more and more of that lit up side until the moon is halfway through its revolution, and now we're looking at the entire half of the moon that's lit up. The full half of the moon that's lit up is in view from Earth. As the moon continues to revolve around the Earth, you'll notice that the shadow is going to appear larger. The next phase after a full moon is called a waning gibbous, transitioning to the third quarter, and finally a waning crescent. Notice how the shadow side on the right gets larger and larger until the moon returns to that new moon phase. And then the process starts again, starting with the new moon, going to waxing crescent, first quarter, waxing gibbous, and then full moon. Back to a new moon by going through waning gibbous, third quarter, and waning crescent. Now, if you're confused as to why the moon phases have these names, it really comes down to two parts. The first is to know a waxing moon versus a waning moon. In a waxing moon, the lit up side is growing. The light is on the right. In a waning moon, the shadow is growing, and the shadow is on the right. Remember, phases kind of work like pages in a book. They always go from the right to the left. So we have waxing and waning. You mix that with a shape. When the moon has this skinny shape, like a banana, that's called a crescent. And when the moon is more than half full, we call that shape a gibbous. I like to think about it like an M&M shape. So we can put these two together. In the example on the left, I can see that the light is on the right, so this is a waxing phase. I see it's that skinny shape, which is a crescent, and so this is a waxing crescent. In the example on the right, I notice that the shadow is on the right, so it's a waning phase, and it's got that big, more than half full look, so that's a gibbous. So this one would be a waning gibbous. Here's your key ideas. Remember, the moon is always half lit up. The phase that we see on Earth depends on how much of the lit side is visible. Keep in mind that phases always go in an order, and that they're named based on which side is lit up and the shape of the moon.